Welcome back to my video series discussing my bad bank 3-tier application developed for my Capstone project. This is part 2, where I'll be going over details about the database and utilized API tools. While state management for error handling is an example of data that is used once then discarded, there's plenty of data in the app that is persistent and stored in my database. Looking at dal.js in my main directory of the application, the create, find, update, and delete user functions interact with the users collection in my database. This collection contains the following fields: name, email, password, and balance. This collection is accessible via the provided URI, a MongoDB Atlas database which provides data persistence. The data access layer, or DAL, is used in my application to interact with the MongoDB Atlas database for the following data operations. Number 1, database connection. The Mongo client is imported from the MongoDB library. The connectDB function establishes a connection to the MongoDB Atlas cluster specified by the URI variable. Then the client variable is declared and initialized with a new Mongo client instance using the provided URI and client options. Number 2, the data access methods. The DAL includes several async functions such as create and update that interact with the MongoDB database using the client object. Each function accesses the badbank database and the users collection using the client.db badbank.collection users syntax. These functions perform specific operations on the user collection, such as creating a user account, finding user accounts by email, updating the balance, retrieving all user accounts, or deleting a user account. The DAL methods are exported as an object so that other parts of the application can access and utilize them without having to refresh the app. So new features I implemented for the DAL are the find one and delete user async functions. The find one function is designed to retrieve a single user account document from the user's collection based on the provided email address. It utilizes asynchronous operations, error handling, and the MongoDB driver's find one method to abstract the database interactions and return the matching document or null if no match is found. The design decision in the delete user function is to use the delete one method from the MongoDB collection to delete a user account based on the provided email, handling any errors that may occur. Moving on to APIs, I'd like to discuss how I implemented the RESTful API. I followed the RESTful architectural style for designing the HTTP protocols in index.js so the clients can easily query the database. Here's how the app adheres to the architecture of the RESTful API. The API endpoints are designed to represent resources, such as account/create. The app uses appropriate HTTP verbs to perform CRUD operations on resources, utilizing get, post, and delete. Each request to the API is self-contained and does not rely on server-side state. The server processes each request independently. The app sends responses in JSON format, which is a common format for RESTful APIs. It provides data payloads and status codes to indicate the success or failure of requests. The app includes error handling middleware to catch and handle errors that occur during request processing. It returns appropriate HTTP status codes and an error message in response to failed requests. The API follows a consistent and predictable interface. It uses clearly defined URL patterns and consistent naming conventions for resources and operations. Finally, the app separates the handling of API requests and business logic. The routes defined in the app delegate the data access and manipulate tasks to the DAL module, which acts as the data access layer. Now let's go over to the API endpoints in index.js. The first endpoint creates a new user account with the provided name, email, and password. This one retrieves all user accounts. Account update updates the balance of user accounts identified by the email with the provided amount. Account/find finds a user account by email. Account/delete deletes a user. Account/check checks if the provided email and password matches a user account. Check email checks if the provided email exists in the database. The endpoints are specified with placeholders for dynamic values such as :name, :email, and :password, indicating that these values will be passed as URL parameters when making requests. Now I will run you through my API documentation, available in the main directory as a .txt file. This is a comprehensive guide that provides information on how to use and interact with the API, including details about available endpoints, request parameters, response formats, authentication methods, and error handling. And just like that, this wraps up part 2. Thanks for watching, and see you in part 3.